Hey guys, Mr. Bowman here. Today's learning objective is in white, and we're learning to calculate the volume of prisms. So as underline that keyword prism, that's the keyword that we need to focus, that we need to understand on before we move on to. So what exactly are prisms? They are three-dimensional shapes. And I want to highlight something. They all have faces, and I'll explain what I mean by that in a little bit. So what I'm going to do is I'm going to draw up the questions that we're going to do in advance. So question 1. So there is a rectangle. So that there is what I call the face of our shape. And then what happens is that face gets extended into a third dimension down like that. And then, so let's have a look at another one, see if that makes sense. Question 2. So here is a right angle triangle. And that there is the face of our shape. And then that shape gets extended back like that. So hopefully that makes sense as well. And then question 3, let's draw up another one. So question 3, there is a trapezium, and that trapezium is the face of the shape, and we'll see that gets extended back as well. And then finally, question 4, we can even do that with circles. There's a circle, and it can get extended back, and that becomes a cylinder. And I'll just put a little F in the middle there, because that would be the face of that shape. So hopefully everyone can see what I mean by that. It's three-dimensionals because it goes up, across, and it kind of goes back into the page. And all of these shapes have what I've described as a face. So let's change pen colors. Let's actually get into the formula that I want us to focus on. So our formula to find the volume, so the volume, that's always going to be equal to the area of the face times the depth. And I'll show us what I mean by both of those. So let's add in some dimensions. So let's say this first shape has a height of 3 meters. It has a width of 4 meters, and then it has a depth of 6 meters. So all of those in meters. How would we go ahead and calculate the volume of that? So the first step is finding the area of the face. And the face, just a note, would be that shaded part there. And that's just a rectangle, and hopefully we all recall the area of a rectangle formula. So the area is going to be equal to base times height, which is going to be 3 times 4, which is going to be 12 meters squared. Once we've got the area, we can go ahead and actually calculate the volume. So I'll do the volume up here. So the volume, that's we'll call it area, AOF, times depth. Apologies about the pen writing. It definitely doesn't like that part of the screen. Depth. So the area of the face, we've already figured out that's 12. And the depth is how much that face kind of gets extended back. So in this case, that there is 6 meters. So 12 times 6. When we do that, that gets us to 72 meters. Well, I've written centimeters, but definitely meters cubed. So hopefully that first one made sense. Let's change pen colors. Let's get into a second example. So maybe we'll go with green this time around. So first step, we always need to find the area of the face. And our face sits along here. So let's make up some numbers just to help with this one. So let's say maybe that's got a height of 4, in this case centimeters. It's got a width of 6. So the area of a triangle is base times height divided by 2. So that's going to be 4 times 6. So there's the base, which is where we get our 6 from. There's the height, which is where we get our 4 from as well. And then that gets divided by 2. That there is 24 over 2, which is, again, by chance, 12 centimeters squared. Now that we have the area of the face, we can go ahead with our volume formula. So the volume is equal to the area of face times the depth. And this time around, let's say our depth is maybe 8 centimeters. So the area of the face is 12. That's going to be times by 8. And let's get our calculator to figure out what that is. So 12 times 8, that's 96. So that means our volume, 96 centimeters cubed. Okay, so let's change pen colors again. So we're now going to go to orange. So here's our face here. So we can see this is the face of a trapezium. So let's say the height of this trapezium, let's say maybe that's 4.5 millimeters. Let's say the roof or the top part up here, let's say that there is 5, and let's say the bottom is 7.5, and maybe the depth is 10. So those are all millimeters. So hopefully you recall, first step, let's find the area of the face, and then we'll multiply that by the depth. So the area of a trapezium, A plus B divided by 2 times height. And in this case, that's going to be 5 plus 7.5 divided by 2 times 4.5. And when you put that into your calculator, so we're going to go 5 plus 7.5, that's divided by 2, and then that's times by 4.5. So that there gets us to 28.125 millimeters squared. And then now that we've got the area, let's go into the easier part, the volume. So the volume is equal to the area of the face times the depth. So that's going to be 28.125 times 10. That gets us to 281.25 millimeters cubed. So hopefully that makes sense. We found the area of the face, and then we multiplied it by the depth as well. Okay, and we'll do our last pen switch to get on to our last question. This time around, let's use the pink pen. So the area of the face, this time around it's a circle, but we can still find the area of a circle. Let's say that there has a radius of 1.2 meters. So we find the area. So in this case, the area is pi r squared. That's going to be pi times 1.2 squared. And then when you put that into your calculator, so 1.2 squared times pi, that gets us to 4.524 meters. And I rounded that to 3 decimal points. Now that we've got the area, let's get into the volume. So the volume is equal to the area of the face times the depth. So this time around, let's say the depth here, maybe that's 12 meters. So it's quite a long cylinder. Maybe it's like a plumbing pipe or something along those lines. So that's going to be 4.524 times 12, which is the depth, or how far the circle goes out. So 4.524 times 12, that gets us to 54.3 meters cubed, and I've rounded that to 1 decimal point. So guys, we went through 4 questions regarding finding the volume of prisms. Just to recap, it's always about finding the volume of the face and then timesing it by the depth. Finding the volume of the face, timesing it by the depth. Finding the volume of the face, timesing it by the depth. And the other thing to note, the units. So make sure you forget units. So don't forget the areas are always centimeters squared. So centimeters squared, millimeters squared over here, and then meters squared over here. And then finally, don't forget that the volume is cubed. So 72 meters cubed, 96 centimeters cubed, 281.25 millimeters cubed, and then 54.3 meters cubed. So hopefully you found this video on finding the volume of prisms useful. Now let's get into heaps of practice.